This video covers the interactive load chart tool, which has been specifically developed for the MATS arm lifting systems. There are a total of 6 different systems, and I should point out that the configuration 1, which is currently shown here, and this will change as each of the configurations are brought up. So that's an isometric picture of the system, and then the dimension description picture is just to the right of that, defining what the particular dimensions are that are shown on the left side of the sheet. So configuration 1, monopole with mast pipe, is useful when we need to get above the top of the tower with our lift system. Configuration 2 is a monopole without mast pipe. This one is useful when we need to be lifting and we are located between sectors or don't need to get above the top of the monopole. Configuration 3, face mount with mast pipe. This system can be used on either a guide tower or a self-supporting tower, with or without sloping legs, and again is useful when we need to get up above the top of the tower, and it can be used whether you're above the top of the tower or not. Configuration 4, similarly to configuration 3, the difference here is we don't have the mast pipe, and it's good for when we're between sectors. Configuration 5, leg mount with mast pipe. Here we're attaching directly to the tower leg and have a mast pipe. Configuration 6 is there is no mast pipe and the beam is being attached directly to the leg, and the top support is attached directly to the leg. Now let's talk about the picture located below the configuration pictures. This one is a representation of the load beam itself, the load beam, the mast pipe, and the bridle and basket beams are all 6061 T6 structural aluminum, roughly equivalent in strength to an A36 steel. The intent is that the load rope will come up and through one of the 5 outer sheaves, come across the beam and drop down through the return sheave down to a heel block, and from there back to the hoist. Now the input on the spreadsheet, all input is outlined in blue and the text is in blue. The output values, and you can't change any of those, they're all protected. They are surrounded by a brown color box, and the text is also in brown. And you should have noticed as I was going through the different configurations that many of the cells and labels turned on or off depending on whether they were needed for that particular system configuration. Now the mast pipe calculations, and let me turn one of those on where we can see it. Alright, the mast pipe calculations and the square tube calculations include the impact factors specified in A322 and A1048. These will change if the steel cable or a synthetic cable is chosen. This will then change the percent capacity of the components, but the maximum load chart values do not change regardless of the type of load rope that you're using. Now, let's run a couple of examples. The first example is going to be a monopole, and we're going to be using configuration number 2. Monopole without mass pipe is going to be used, as we will be replacing antennas with built-in remote radio heads. The maximum antenna weight is 180 pounds. I've added another 40 pounds for rigging and rope weights. So let's do that right quick here. So we've got 220 pounds. We're going to stay single part. Now the vertical connection distance, as you see in the dimension descriptions, is the distance from the beam connection to the rope connection. Now, the sectors make a complete platform with a required maximum reach of 65 inches to be able to work on 2 sectors with one setup. So we're going to try picking from sheave number 3, and we're trying to achieve a reach of 69 inches. And if we see here, we see that the maximum lift capacity was 1,200 pounds, and the tower face to sheave number 3 exit is 69 inches. So we did not need to tilt the beam up to revise that. And if we want to then see the reactions, specifically if we need an engineer, we go to the button in the lower right that says go to reactions page, and here it says cable, beam and cable connected to monopole, and gives the engineer the vertical and horizontal reactions at both of those connections. Now, the second example is a bit more complicated. I've got a guide tower, so I'm going to come up here for record purposes and say guide tower. This one has a 48-inch face, bracing connection spaced at approximately 30 inches center to center. I need to place new sectors at the top of the tower. The sectors are to be independently attached to the legs. Each of the sectors weighs approximately 900 pounds, and I've added another 50 pounds to account for rigging and rope weights. So I want to use configuration number 3. Using this system, I can get above the sectors. If I locate the mass pipe in the center of the face, and you'll note here there is a mast offset from center, and it's currently set at 0, indicating that we're at the center of the face. From this location, I can reach all 3 legs with one setup. The bridle and basket beams will be about 45 inches apart. So let me set that to 45. The tower face width is already set at 48 inches. Now, the centroid of my load is about 24 inches out from the leg. The center of the mass pipe is about 16.5 inches out from the face. And in this particular case, in order to do all 3, we're going to reach all the way around to the other side of the tower. Therefore, my maximum reach will be to the far leg. The distance to the centroid of my lift will require me to use sheave number 4 at this location. So let me change my weight here. I didn't do that. That's 950 pounds. We're using sheave number 4. We're lifting 950 pounds, and we have an available lift capacity of 1,000 pounds. The results then, let's see if I've got everything changed here. The results now show that We have 91.5 inches out to sheave number 4, but I got to back up about 16.5 inches. My mass pipe is going to be at 87.7%, and my bridle and beam basket beams are at 22.7%. And if we go to the reactions page, again, here are the loads for that maximum reach. I hope you have understood this presentation, and if you have any questions, feel more free to contact me, Bill Griswold, at live.com, or telephone number 704-906-9113.